This integral looks simple, but the modulus makes it tricky. Watch and learn the smart way to split it. We are supposed to integrate modulus of x cube minus x between the limits minus 1 and 2. To that end, let us consider x cube minus x. If we factorize this, we get x into x minus 1 into x plus 1. You can notice that x minus 1 into x plus 1 is x square minus 1, and x square minus 1 into x is nothing but x cube minus x. If we equate this expression x into x minus 1 into x plus 1 to 0, we get three critical points. One is x equals 0, another is x equals 1, and another will be x is equal to minus 1. Now consider the number line and divide it into three intervals by taking the critical points minus 1, 0 and 1. Here in the last interval, the end point is taken as 2, as we have upper limit here is 2. Now we have to check the behavior of x cube minus x in these three intervals. First, let us consider the interval from minus 1 to 0. That is, x lies between minus 1 and 0. Choose a point between minus 1 and 0. Then x will be minus and x minus 1 will be minus and x plus 1 is plus. That means when you choose a point in the interval minus 1 to 0, this x cube minus x is positive. Let me explain it. Let us choose x is equal to minus 0.5. Minus 0.5 means it is negative. When you put x equals minus 0.5 in the second term, we get minus 0.5 minus 1, which is again negative. And in the third term, when you put x is equal to minus 0.5, it is 1 minus 0.5, which is 0.5, which is also positive again. Therefore, minus into plus, which is greater than 0. That is, it is a positive quantity. X cube minus x is positive in the interval minus 1 to 0. Similarly, let us check the behavior of x cube minus x in the interval 0 to 1. In the interval 0 to 1, x cube minus x is negative. If you take a number, that is, if you choose a real number between 0 and 1, say x is equal to 1 by 2, then x is positive, and 1 by 2 minus 1 in the second term gives as negative quantity. And in the third term, we have 1 by 2 plus 1, which is 3 by 2 plus 3 by 2, that is, we are taking here as positive quantity. So plus into plus is negative again. Therefore, x cube minus x is negative in the second interval, that is from 0 to 1. Next, let us consider the third interval, that is from 1 to 2. Choose a point between 1 to 2, say 1.5. Now x cube minus x will be, here x is 1.5 positive, and 1.5 minus 1 is again positive, and 1.5 plus 1 is also positive. So clearly x cube minus x is positive in the third interval, that is between 1 to 2. So now we understood that in the first interval minus 1 to 0, x cube minus x is positive. In the second interval, that is from 0 to 1, it is negative, and in the third interval, that is from 1 to 2, it is positive. Now let us split the given integral of minus 1 to 2 of modulus of x cube minus x. In the first interval, that is minus 1 to 0, we have seen that x cube minus x is positive. That is why modulus of x cube minus x is nothing but x cube minus x. In the second interval from 0 to 1, it is negative. That means this modulus of x cube minus x is taken as minus of x cube minus x. In the third interval, that is from 1 to 2, it is again positive. Therefore, modulus of x cube minus x is x cube minus x. So we got integral minus 1 to 2 of modulus of x cube minus x is minus 1 to 0 of x cube minus x, that is positive here as it is positive in the first interval, and in the second interval it is negative, therefore we have minus of x cube minus x, and in the third interval it is positive, so we are taking it as x cube minus x in the third interval from 1 to 2. Now let us evaluate each integral one by one. Let us consider first integral. We have the limits from minus 1 to 0 of x cube minus x. So that is, when we integrate this, we get x to the power of 4 by 4 minus x square by 2 between minus 1 to 0. Similarly, in the second integral, we have minus of x cube minus x. That means it is nothing but x minus x cube, whose integral is x square by 2 minus x to the power of 4 by 4 between 0 to 1 here. And the third integral, x cube minus x, gives us x to the power of 4 by 4 minus x square by 2 after integration, and the limit is 1 to 2. Now let us evaluate. Let us apply the limits. So we get first term, that is upper limit. When we put x equals 0, we get 0. When we put minus 1, we get minus 1 whole to the power of 4 by 4, that is 1 by 4, and minus 1 whole square by 2 is 1 by 2. Similarly, we can evaluate the second term, which gives us 1 by 2 minus 1 by 4 minus 0. That is, when we put x equals 0, all the terms vanishes. Let us evaluate the third term. When we put x is equal to 2, we get 16 by 4 minus 4 by 2. Minus of, when we put x equals 1, we get minus 1 by 4, and minus of minus 1 by 2, which is plus 1 by 2. So take 4 as LCM and simplify, we get minus 11 by 4. Therefore, the value of integral of minus 1 by 2 of modulus of x cube minus x dx is nothing but 11 by 4. Try solving integral of 1 to 3 of modulus of x minus 1 plus modulus of x minus 2 plus modulus of x minus 3 without looking at the solution. Comment your answer below and tag a friend who should try this too. Don't forget to like, share and subscribe for more smart maths tricks.